My name is Tim Dolen. I'm a consulting civil engineer. I've been working for about 4 or 5 years consulting on dam projects around the world, specifically roller compacted concrete dams. But before that, I was worked for the Bureau of Reclamation concrete laboratory for 33 years, which is where I first became involved in designing in concrete mixes. My first work in concrete was actually as a junior civil engineering student at Bucknell University on the concrete canoe competition. And I was captain of the canoe to make a lightweight concrete so we could enter this competition. Almost immediately, I was hired in to be designing concrete mixes, and the Bureau of Reclamation had been a leader in using pozzolans in concrete for more than 50 years at that time. So I was first exposed to pozzolans almost from the very first day that I started working in 1978. The Bureau was using natural pozzolans in mass concrete to reduce temperature rise and thermal stresses in massive concrete dams. They're also using it as a supplementary cementitious material and for better durability, specifically for durability against sulfate attack and alkali aggregate reaction. The Bureau and the Corps of Engineers worked together through both of their laboratories, so there was a lot of communication between the two. And I believe the first use of pozzolan in the West was actually a Corps project at Bonneville Dam, but the Bureau had been using pozzolans in several other structures leading up to that time. And I think because of being in the Western United States, an agency of the Western United States, that they had more exposure to natural pozzolans. Well, number one, the Bureau used this to save money. Natural pozzolans and pozzolans in general were cheaper than cement. And coupled with the beneficial effects for reduction in temperature rise and thermal stresses and the added benefits for durability of concrete, it was done to reduce the cost of the concrete as well. One of the first structures that I ever worked on associated was Altus Dam in Oklahoma. And the thing that struck me is this dam was built quite a bit different than the normal dams using big block construction. It was actually faced with granite stones and placed in horizontal layers across the dam, and it used a natural pozzolan. The reason that is important to me is because my work in roller compacted concrete, where we're building structures horizontally from one abutment to the other in thin layers, very similar to Altus Dam. The strength, the long-term strength there was quite high. We did studies many years afterwards on cores taken from the dam. So the strength of the material was quite high, and the cementitious materials contents were very low, even the cement and cement plus pozzolan. So it got pretty good strength for very low cementitious contents. Number one benefit is in reduction in alkali aggregate expansion. Large dams, even small expansions, can be quite difficult to mitigate. And to have very long service life. Our dams that we were working on were intended to last 75 or 100 or more years. So the long-term volumetric stability of a massive structure is extremely important to its service life. I've really not encountered any really significant failures of concretes used in pozzolans in general or natural pozzolans. And in fact, when we looked at the strengths of cores drilled from Friant Dam, not all of the dam used pozzolans and low alkali cement. And there were some sections near the top of the dam, I can't remember why, that used a higher alkali cement and suffered from alkali aggregate reaction that suffered a very dramatic or costly repairs. And I've looked at the properties of mass concrete in many dams all around the Bureau of Reclamation dams and many other dams around the United States. And it was very dramatic, the difference in strengths of dams that use pozzolans and how they mitigated the alkali aggregate reaction. Well, I do believe that we have a significant infrastructure crisis right now. Structures that were built a long time ago, actually built very well, are nearing the end of their service life. And in that context, they were built using the best of materials, the best quality construction, and they took a lot of consideration on long-term durability. What I see now is a rush to build things bigger or faster and cheaper, and with very little consideration for the long-term durability of the structure and who's going to pay for it when it has to be redone. We have to pay for our current infrastructure crisis, and we need the best materials available to build durable structures. And because we do not have as good a quality of materials available, we need to have the best tools in our little work set to get most durable concrete. And Pozzolans play a very significant role in the future for that. I would think that from what I'm seeing right now, actually in the residential concrete industry could greatly benefit from using Pozzolans more effectively to build better quality concretes, more impermeable and more resistant to the deleterious mechanisms, especially in the western United States, with alkali aggregate reaction and sulfate attack. And I don't feel it's being used that effectively. I think, to me, the industry has been driven down by short-term measures to do concrete as cheaply as possible, and I don't think the long-term durability is being considered sufficiently. And with the challenges of the materials we have available, I think we can use Pozzolans effectively to make more durable concretes. I guess one area that might be very important is we use a lot more crushed materials than we've used in the past. So there is a need for better workability in the concrete. So in that sense, I think that Pozzolans are important to provide sufficient paste volume to these very, very abrasive almost mixes. At the same sense, we're using smaller and smaller aggregate sizes. So the paste content is being driven up because of small aggregates. So the cost is being driven back up, and cement contents will have to rise. So the Pozzolans can be an effective supplementary material for the smaller size aggregates you're seeing on a lot of jobs. So in that sense, we're going to get more and more problems with temperature-related issues from the higher cementitious materials contents, and Pozzolans can effectively mitigate some of that. One thing that has significantly changed in the concrete industry since I started was the use of pumped concrete. In the past, pumping was used to get material to a location that was very difficult to get into. Like a tunnel, you would have to be pumping concrete down there. But now, pumped concrete is used for everything as a substitute for people. You can pump concrete much quicker and easier and cheaper than you can use a bunch of people with wheelbarrows and skips to get it from one point A to point B. But with pumped concrete comes smaller aggregate sizes and higher paste volumes that come up. And whenever you drive up the paste volume, it drives up the cost. And using the Pozzolan effectively in a more workable mixture helps you with pumped concrete. In fact, they used to put in additives to make concrete more pumpable. So I would say that's probably the biggest change that I've seen in the concrete industry was the reliance on using pump trucks to get concrete in place. Not necessarily meaning that it's bad, but because of the smaller aggregate sizes, it affects the concrete mixture significantly. They have used some additives to try and improve the pumpability of concrete over time. I think originally they used that because it was more difficult. I think with the more modern materials and such, perhaps it's it's not added strictly as a pumping aid, although I still hear that as a pumping aid. Not necessarily sure whether it's natural pozzolans being used or whichever, but there used to be pumping aids added in small quantities to improve the pumping.